learning RBF kernels and SVM regression. So we have in the last session we have looked at SVM, how it works with linear regression, and also we have known that SVM works for both a regression type and a predict or a classification type problems. So we have looked at quite a few things with respect to C parameter, how overfitting and underfitting uh, is like in polynomial kind of Moon's dataset specifically. So we are going to be extending the same learning. In this session, we are going to be looking at RBF kernel and SVM in regression. So we are going to be starting off with similarity features. Consider we are at a location. Let's say um, the far away that we are at, we say that the similarity feature decreases, right? Like for example, you move to the north of so let's say a person in India going south might experience a different kind of features with people, while at the same time he travels to the north, he might see different features on a person, right? So that's a basic example. So as you move far away from a specific location, the features tend to separate a lot more. Similarly, gamma is one such parameter which informs us the similarity features, or the way that the similarity increases or decreases. So as you can see, Gaussian similarity, we have a, as we increase in distance, the similarity starts uh, increasing, right? uh, at 0 we have almost 0, or we have high similarity. As we increase, the similarity score decreases. Gamma is a parameter which controls the way the effect of the similarity. Either it can decrease sharply when we have larger gamma values, or when we have a lower gamma values, it can uh, decrease slowly, right? So that's one thing. um, Large gamma values mean a larger drop, or it corresponds to overfitting, while a small gamma value means there is influence over a larger region, and it is corresponding to underfitting. So there needs to be a balance. So in case of nonlinear dataset or a polynomial kind of dataset, this is again a Moon's dataset. We can have RBF, uh, kernel RBF, and we can set gamma values and C parameters, and we can classify or have a machine learning model built out. And this gives out a result something like this, right? So we are having to create this model with uh, values like this, with also some amount of noise values as well, right? So that's one thing. And next is uh, gamma and model complexity. So with respect to gamma values, uh, very low gamma value means wide and smooth, and it corresponds to underfitting. The other way around for the other parameters, right? We have understood how combination of these two works here with an example as well, right? So do play around with it and see that the optimal values are around 1, and it gives out best train and test score, while gamma at low gives out both train and accuracy low. While we increase gamma value, train accuracy increases. This is overfitting, while test accuracy decreases, clearly showing an overfitting pattern. So similarly, we are also having to find out patterns with C and gamma parameters and see the results here. Similar to the last one, at this point there is a balanced fit. Um, so SVM regression is another model which can help in such kind of datasets. It's not a linear model, but a model which has some regression type values associated to it, and we can have a machine learning model built out this way. And there is one thing here to note: epsilon is a parameter that controls the thickness or the width of this SVM regression. So that's one thing. Okay, so that was quite a bit of things. So there are few formulas here with epsilon. Epsilon is again similar to gamma understanding, so would not be spending much time here. So those were few key points or few things to introduce in this learning with SVM. Hope you found this video helpful. Please do like, share, and subscribe to my channel, and post any thoughts or any discussion points in the comment section. Happy to respond there as well. Thank you.